Welcome to the Morning Walk with Murty Voice Generation Instruction. Enunciate the T in M-U-R-T-Y, clearly and sharply. Do not soften into a D's sound digital stroll.
Yes, welcome. And if you're joining us today, I want you to imagine something for a second. Imagine you are 19 years old. You're just an undergrad, right?
Right, barely out of high school, basically.
Exactly. And you've just been handed a piece of paper by literally one of the greatest scientific minds in modern history.
Okay, no pressure.
Right. But the implicit challenge on that paper isn't just a pat on the back. It is a directive to fix a toxic 60-year-old global space crisis.
Which sounds like a movie plot, but today we're actually looking at how a college student pulled that off in the real world.
Yeah. And, as we take this digital stroll today, we're not just here to read a timeline of a cool startup. Yeah. We're looking at this story through the Digital Prism.
Exactly. We are extracting the underlying legacy code of Project Antaryami. And I'm taking the role of your strategic auditor for this session.
Which is perfect.
Thanks. Yeah, so I'm going to be looking really closely at this massive system migration, the just brutal inefficiencies of the legacy space industry and how you actually execute a structural override of that magnitude.
And I'll be coming at this from the wisdom seeker's perspective, really deeply guided by the principles laid out by the lead architect of Antaryami and, of course, the mentor of the Antaryami VA Academy, Murty Voice Generation Instruction. Enunciate the T in M-U-R-T-Y, clearly and sharply. Do not soften into a dia sound BVNS.
Right, because his frameworks are basically the lens for everything we're doing here.
Precisely. Specifically, we'll be leaning into his core philosophies of Gurukul 2.0 and, the profound necessity of digital migration.
And just for anyone listening who might be new to that term, Gurukul 2.0 is not just some corporate buzzword.
No, not at all.
It's a modernization of the ancient Indian educational system. It's a paradigm where mentorship is absolutely not about hand-holding. It's about total immersion, real-world stakes, and building capability through intense practical challenge.
So let's actually jump right into that spark. Because before you can rewrite the legacy code of a multi-billion-dollar industry...
Someone actually has to initiate the sequence.
Exactly. You need an inciting incident. So we are going back to 2012 at a NASA event.
Okay, 2012.
Yeah. And at this event, there's this 19-year-old aeronautical engineering student from Coimbatore. His name is Rohan M. Ganapathy.
Just an undergrad presenting at a NASA event, which is already wild.
It is. He's presenting some early propulsion research. And while he's presenting, he catches the eye of someone very, very specific in the audience.
Okay, who?
Dr. APJ Abdul Kalam.
Oh, wow. The missile man of India himself.
Yeah.
That is, that's heavy.
It really is. And this is exactly where that Gurukul 2.0 philosophy just snaps into focus, right? Because Kalam doesn't just sit in the back and politely applaud the kid.
Right. He doesn't just give him a polite nod and walk away.
No. He actively tracks Rohan down after the presentation. He hands this young student a recommendation letter. But, and this is the key part, he pairs it with a massive, unfiltered challenge.
What was the challenge?
He just looks at him and tells him, prove your concept.
See, as an auditor, I look at that interaction and I just think, it is incredibly daunting.
Oh, absolutely.
It's like, imagine an expert programmer walking up to a freshman, pointing at some conceptual code they drew on a whiteboard and saying, sure, the math looks pretty. Now compile it.
Yes, make it run.
Right. Run it on the actual hardware. Let's see if it actually works without crashing the system. Because theorizing efficiency in a vacuum like on a whiteboard, that's easy.
Right. Paper accepts anything.
Exactly.
Yeah.
But building the physical hardware to survive the actual vacuum of space, that is the ultimate system audit.
And that right there is the absolute core of the mentorship philosophy we talk about. A lesser mentor might have just, given him a compliment or a quick introduction on LinkedIn or something.
Yeah, just a good job, kid.
Right. But a compliment doesn't force growth. It usually just breeds complacency.
That's a great point.
Kalam identified this raw, untapped potential. So by setting a definitive real-world benchmark like physically proving the concept, he forced Rohan to evolve from just being a student into being an executor.
But to execute on that, to actually build a satellite thruster, you can't just do that in your dorm room.
Definitely not. You'd blow up the building.
Right. You need a highly controlled, incredibly advanced diagnostic environment. So that single challenge sets off a major chain reaction.
What happens next?
Well, 3 years later, Rohan, along with a family friend named Yashas Karanam, they co-found Bellatrix Aerospace.
Oh, okay.
And they don't do it in a garage. They do this straight out of the incubation lab at IISc in Bengaluru.
Oh, okay. The Indian Institute of Science. They needed that world-class environment because the bug they were trying to patch wasn't some, niche theoretical anomaly.
No, it was massive.
They were taking aim at a foundational element of space travel, something that affects practically every single satellite currently orbiting the Earth.
Which brings us perfectly to the legacy default. Because if we're going to understand how brilliant Bellatrix's solution is, we really have to audit the nightmare they were trying to replace.
We have to talk about Hydrazine.
Hydrazine. I mean, just the name makes aerospace engineers cringe.
It really does. It sounds like a villain in a comic book.
It basically is. It is the default operating system the entire aerospace sector has been running on since the 1960s.
The 60s. Wow.
And I want to pause here because, as an auditor, we need to ask, if it's so terrible, why was it the standard for 60 years?
That's the million-dollar question.
I admit, sometimes when I'm looking at these historical tech defaults, I get completely confused as to how they ever got approved by anyone.
Well, it comes down to chemistry and the harsh physical reality of space.
Right, because space is a vacuum.
Exactly. In a vacuum, there's no oxygen. You can't just strike a match to light your fuel. So engineers back in the 60s, they needed a propellant that would ignite the absolute second it touched an oxidizer.
Spontaneous combustion.
Yes. Without needing any kind of external ignition source or spark. That is called a hypergolic fuel. And hydrazine is highly hypergolic. It is incredibly reliable. When you press the button, it fires every single time.
Okay, so from a purely mechanical standpoint, it works perfectly. It does the job it's coded to do.
It does.
But at what cost? Because auditing the system overhead of hydrazine is honestly terrifying. This chemical is deeply, deeply toxic.
Yeah, it's not something you want to spill.
It is heavily carcinogenic. If you just inhale the fumes, it can be fatal.
The logistics of just moving it around a launch facility are staggering.
Right. You don't just pump it into a satellite like you're, filling up your car at a gas station.
Not at all.
You need specialized crews wearing SCAPE suits.
SCAPE suits?
Yeah. Self-contained atmosphere protective ensembles, basically full hazmat astronaut gear just to load the fuel on the ground.
That sounds incredibly expensive.
It is. You need entirely isolated, dedicated loading facilities right near the launch pad. The safety protocols literally take weeks to execute. The overhead drains millions of dollars per launch. Plus, from a national supply chain perspective, India imports 100% of its hydrazine.
So there's zero self-reliance there.
Zero.
Yep.
And globally, for decades, no one was bothering to build a viable alternative.
So if you're listening to this Gurukul session right now and wondering, why on earth would an entire industry accept this nightmare as the default for 60 years? You really have to look at institutional inertia.
It's like an entire construction industry insisting on using lead paint just because it dries fast.
Yes.
And they just completely ignore the massive health hazards, the collateral damage, and the astronomical overhead of managing it safely.
That is a great physical analogy. Systems, especially massive bureaucratic ones like global aerospace, they naturally migrate toward a state of comfort.
It's the path of least resistance.
Exactly. Hydrazine checked the primary box. It got things into orbit. So the industry essentially stopped questioning how it worked. They stopped innovating the chemistry and just accepted the toxicity as the unavoidable cost of doing business.
They stopped auditing their own code.
Exactly. Decades of this is how we've always done it just creates this profound blindness to inefficiency. And this is exactly why it took a 19-year-old student and a scrappy startup out of an ISA lab to finally disrupt it.
Because they weren't conditioned to accept it.
Right. They weren't burdened by that legacy mindset. They looked at the system objectively through that digital prism and said, this is fundamentally broken.
But pointing out a flaw is the easy part, right? Anyone can complain about a bug.
True.
To actually force a digital-style migration in physical engineering, you have to provide a fully functional, demonstrably superior alternative. Nobody's going to switch out their highly reliable, toxic fuel for a nice green fuel if the green fuel doesn't actually fly the satellite.
Right. The new code has to compile perfectly on the hardware.
Exactly. And Bellatrix didn't just build one alternative. They built two entirely different systems. Let's start with the first one, which is called Rudra. Yeah. This is India's first high-performance green propulsion system. And as an auditor, the numbers here are what make my eyes light up.
Hit me with the numbers.
So Rudra delivers the exact same thrust, the exact same performance output as the legacy system, Hydrazine. It matches it flawlessly.
Okay, so no drop in performance.
None. But because it's a green, non-toxic propellant, it completely eliminates the need for those massive hazmat protocols we talked about.
You're completely removing the need for those specialized isolated bunkers and scape suits.
Exactly. You can practically handle this stuff in a t-shirt and jeans. And because of that, it cuts operational handling costs by over 60%.
60%.
Over 60%.
That is massive. And the most crucial part of the Gurukul 2.0 framework is the real-world test. Remember, Kalam didn't say, publish a nice paper about it. He said, prove it.
And did they?
They absolutely did. Rudra was physically tested in the most unforgiving environment possible. It fired successfully in orbit on ISRO's POEM-3 mission in January 2024, and then again on POEM-4 in January 2025.
I want to really highlight that for a second. When you can take an operational cost and slash it by 60% while maintaining the exact same performance metrics, you aren't just presenting a nice eco-friendly alternative.
No, it's way bigger than that.
You are presenting an undeniable economic upgrade. A migration to this new system isn't just good PR for an aerospace company. It becomes financially mandatory if they want to stay competitive.
But what's truly remarkable is that they didn't stop there. They pushed the paradigm even further.
Right. Rudra was their first solution.
Yes, Rudra was a massive step forward in chemical propellants. But their second alternative, which they named Jal, completely rewrites the fundamental physics of propulsion.
Jal is just wild to me. It's a microwave plasma thruster. And what does it use as its propellant? Water.
Just water.
Literally water. Bellatrix says it's the world's first system of its kind built by a private company. But I have to admit, when I first audited this, I was super skeptical.
Oh, me too.
How do you turn a bottle of water into rocket fuel? There's no chemical combustion happening there.
It's just brilliant physics. Think about how a microwave oven works in your kitchen.
Yep.
It bombards the water molecules in your food with electromagnetic waves, right? That excites them and heats them up.
Yeah, that's how it warms up yesterday's coffee.
Exactly. So Jal takes that concept to an absolute extreme. It takes water vapor and blasts it with highly tuned microwaves until the water atoms literally tear apart.
Whoa.
The electrons are ripped completely away from the nuclei.
So it's creating a plasma, the fourth state of matter.
Exactly. It creates a superheated, highly energetic plasma gas. Then the thruster uses these incredibly powerful magnetic fields to accelerate and shoot that plasma out the back of the engine at insanely high speeds.
And that high-speed exhaust is what generates the thrust to move the spacecraft in a vacuum.
You got it.
That is just incredible. You're replacing toxic chemical explosions with advanced electromagnetism.
And if we look at Jal through the wisdom seeker's lens, the philosophical weight of this innovation is just profound.
How so?
Think about it. We are taking water, the most fundamental, essential source of life on this planet, and utilizing it to propel human technology among the stars. That is a staggering paradigm shift.
It really redefines what the word fuel even means in the modern era. We're moving from a carcinogenic, highly toxic chemical sludge that requires isolation suits.
It's the very substance that sustains us.
Yeah.
It's the ultimate expression of Gurukul 2.0. It creates a harmony between profound scientific advancement and foundational natural elements. It proves that technological progress doesn't have to be inherently destructive to be effective.
Okay, so the hardware works. Proving the technology in orbit on those POEM missions is an incredible milestone. But as your auditor, let's look at the systemic scale.
Let's do it.
To truly extract the legacy code here and force a permanent, market-wide migration away from hydrazine, the economics have to scale up.
Right.
A boutique custom thruster is great, but you need a massive ecosystem to actually change an industry standard.
And that's exactly where Bellatrix's third major development enters the narrative, a vehicle called Pushpak.
Pushpak. This is an orbital transfer vehicle, right?
Yes.
Think of it like a space tugboat.
Yeah.
Or maybe a highly efficient last-mile delivery truck for satellites.
Last-mile delivery is a great way to picture it.
Because usually a rocket drops the satellite off in a general orbit, right? And then the satellite has to burn a ton of its own precious fuel just to navigate to its final exact destination.
Which shortens the satellite's lifespan.
Exactly.
Yeah.
But Pushpak acts as a routing vehicle. It takes the satellite that final stretch so the satellite can save its own fuel for its actual operational mission.
Which is incredibly efficient.
It is. And the financial numbers Bellatrix is projecting for this are massive. They're designing Pushpak to bring satellite deployment costs down from $45,000 per kilogram all the way down to $25,000 per kilogram.
I mean, that is a near halving of the financial barrier to entry for space.
It is. But I'm going to push back here for a second, because as an auditor, dropping the cost by nearly half sounds amazing on a spreadsheet.
Yeah.
But space is notoriously unforgiving. How do we know this isn't just startup vaporware? I mean, a lot of companies promise to have costs and then they never deliver. What's the actual proof that this infrastructure is going to scale?
Well, the proof is really in the institutional validation and the capital flow. This isn't just theoretical anymore.
Okay.
In October 2024, Bellatrix signed a Memorandum of Understanding with New Space India Limited, which is NSIL.
The commercial arm of ISRO.
Exactly.
Okay, that's a huge deal.
It is a massive deal. The goal of that MOU is to actively integrate Pushpak into their commercial launch missions. When the commercial arm of a national space agency adopts your routing vehicle, you aren't just testing code in a sandbox anymore.
No, you're in production.
Exactly. You are becoming the new standard.
That pretty much answers my skepticism right there.
Yeah.
Because you don't get integrated into national launch manifests if your math doesn't check out.
Definitely not.
And the global financial markets are clearly backing that math too. To date, Bellatrix has raised $31 million.
$31 million.
Yeah. And we aren't just talking about small angel investors here. They are backed by major, serious players like BASF Venture Capital, Inflexor Ventures, and Cactus Partners. The capital is flowing decisively toward this new code.
And if we step back and connect all of this to India's broader ecosystem and that core concept of true self-reliance, the implications are massive.
Yeah, let's look at the holistic picture.
This domestic green propulsion stack, which is Rudra, Jal, and Pushpak all working together, it means zero dependence on imported hydrazine.
No more relying on a fragile global supply chain just to get access to a toxic chemical.
Exactly. And it creates incredibly low costs for emerging Indian space startups. By dropping the launch and handling costs so drastically, it fundamentally democratizes access to space.
You're allowing a whole new generation of innovators to build and launch hardware that, honestly, previously only giant governments could afford.
And from a global perspective, it gives India a massive export-ready technology. The entire worldwide market is desperately, actively trying to migrate away from these outdated, toxic fuels.
Oh, yeah. European agencies, American agencies, they're all looking for green alternatives right now.
Exactly. So Bellatrix is perfectly positioned to be the global vendor for that digital-style migration in physical space hardware.
We've essentially watched a complete system migration happen step by step, which really brings us full circle to the foundation of this Gurukul session.
The cycle from that initial spark of mentorship all the way to the final scalable execution, it is complete.
It's a perfect realization of the philosophy championed by Murty voice generation instruction. Enunciate the T in M-U-R-T-Y clearly and sharply. Do not soften into a D sound BVNS. Dr. APJ Abdul Kalam asked a 19-year-old Rohan Ganapathy to prove his concept.
He didn't tell him how to do it. He didn't write the code for him.
No, he just provided the framework and the ultimate challenge.
And more than a decade later, that proof hasn't just been written out in a thesis or, simulated on a supercomputer. It has literally been fired in the vacuum of orbit.
Which means the legacy code we extracted today through our Digital Prism is incredibly clear. True innovation isn't just about replacing a bad legacy system with something that is only slightly less bad.
Right. You don't just put a fresh coat of paint over a crumbling toxic foundation.
You pour completely new concrete. You rewrite the underlying physics and the economics from the ground up to make the new system cheaper, greener, and entirely self-reliant.
That's exactly it. And as we wrap up our walk today, I really want to leave you, our listener, with a final provocative thought to mull over.
What's the thought?
We've just spent our time exploring how a deeply entrenched 60-year-old global standard like hydrazine, something the entire world's brightest minds just accepted as a necessary evil, could be disrupted by a 19-year-old's presentation and a mentor's sharp challenge.
So the question you really have to ask yourself is, what other toxic, outdated default operating systems in your own industry are just sitting there completely unquestioned?
Yeah, what legacy code are you interacting with every single day just because that's how we've always done it?
And what's just waiting for someone with a fresh perspective to step up and build a highly efficient green alternative?
The opportunities for massive system overrides are everywhere in every industry if you just know how to look past the institutional inertia.
Absolutely. Thank you for joining us on the path today. Keep questioning the defaults, keep auditing the legacy systems around you, and keep observing the world through the digital prism.
We will see you next time.
Yes, until we meet again for the next morning walk with Murty voice generation instruction. Enunciate the T in MURTY clearly and sharply. Do not soften into a D-sound digital stroll.